In this example, we are asked to apply the divergence test to the series sum from n equals 2 to infinity of 9 root n over ln of 5n. As with all applications of the divergence test, we're simply looking at the limit as n goes to infinity of the terms, 9 root n over ln of 5n. And say what happens? Well, a radical, ln goes to infinity, but pretty much as slowly as possible. This is not one that we looked at with our hierarchy of functions as far as logarithms and polynomials and so on. So let me actually do this one a little bit more directly. And how does that hierarchy of functions come about? It essentially comes about by L'Hopital's rule. Let's apply L'Hopital's rule in this example. If I apply L'Hopital's rule, this is infinity over infinity, which is why we can apply L'Hopital's rule. But this is 9n to the 1/2. So the derivative of 9n to the 1/2 is 9 times 1/2 times n to the minus 1/2. Derivative of ln of 5n is 1 over 5n times 5. So this becomes the n to the negative 1/2 will go down to the denominator, the 5's will cancel, 1 over n will come up to the numerator, so this is actually 9. So I have a 9 in the numerator, the 2 is the denominator, the n to the 1/2 is in the denominator, and then I have an n which is up in the numerator. So n over n to the 1/2 is n to the 1/2 in the numerator. By subtracting exponents. N to the 1, 1 minus 1/2 is 1/2. What is the limit? That's a square root. Square root still goes to infinity. So this still goes to infinity. So in fact, a radical of a polynomial still dominates a logarithm as well. So this tells me that the series diverges because the terms do not go to 0.